So dear students, today we are going to discuss about transients. Before discussing transient, the circuit theory can be analyzed in two different ways. One is frequency domain, another one is time domain. So all the units in electric circuit analysis, we discuss the circuit theory or circuits by using frequency domain. But transient is concerned, it is time based. So transient is depend upon time. So we have to analyze the transient only by time domain. So you must know what is the voltage across the capacitor, what is the voltage across the inductor, and what is the voltage across the resistor in time domain. For in frequency domain, what is the voltage across the inductor? It is I into XL. What is the voltage across the capacitor? It is I into XC. But in the time domain, what is the voltage across the resistor? That is equal to I into R. That is almost similar to frequency domain. So V is equal to I into R. Right? Similarly, what is the voltage across the inductor? That is L into di by dt. So what is the voltage across the capacitor in time domain? 1 by C integral I dt. So you must know these three. Then only we can analyze the circuit. So we can analyze the transient in circuits. So you must know what is the voltage across the inductor, what is the voltage across the capacitor, and what is the voltage across the resistor in time domain, because we are analyzing the transient in time domain. The transient will occur only for a short duration. So we have to analyze only in time domain. That's why, so we are writing the equation in time domain. All the other units you are analyzing the circuit by frequency domain. Similarly, before entering the circuit, you must know what is meant by transient state. Actually, the circuit consists of energy storing device. So, three passive components that involved in circuit theory. One is the inductor, other one is the capacitor, other one is the resistor. Among these three, the inductor and the capacitors are energy storing device that will store some amount of energy into it. So, that's called it is energy storing device. The circuit consists of energy storing device. If you switch on the excitation, if you give excitation into the circuit, the current flow into the circuit, it will take smaller time because this is the energy storing device, inductor is the energy storing device, capacitor is the energy storing device. So that will store, initially that will store energy into it. That will take smaller time. Then only a steady current will flow through it. Suppose a circuit that consists of only resistance alone, it is not an energy storing device. So if you switch on the switch or if you switch on the excitation, immediately steady current will flow through the circuit. But in the case of the circuit consists of energy storing device, immediately the steady current. What is meant by steady current? The current or voltage that doesn't change with time. That's called steady. Steady voltage or steady current. So when the circuit consists of energy storing device, so the steady current will not flow immediately because so the storing device that will store some amount of energy, then only steady current will flow through that. So a circuit consists of energy storing device. If you switch on the excitation, so a steady current will flow through that. It will take smaller time. So initially when the switch is open, in this case when the switch is open, so there is no current, zero. That is also a steady state because the zero doesn't change. So for a period of time it is zero. When you switch on the switch, immediately this excitation due to this voltage, the current will flow through it and it will take smaller time to reach the steady state. So what is the transient state means? Change from one steady state to another steady state. That's called transient state. So the circuit consists of energy storing devices. If you switch on the excitation, the circuit change from one steady state to another steady state. So that's called transient state. What is transient time? The time taken for the circuit change from one steady state to another steady state. So the time required to change from one steady state to another steady state. Already I told that initially it is zero, there is no current because the switch is open. When the switch is closed, the current flow through it. The steady state current will not flow immediately because it consists of energy storing device. It will take smaller time to reach the steady state. The time taken for the circuit to change from one steady state to another steady state is called transient time. The time taken for that. Another one is natural response. What is natural response means? the circuit doesn't consist of source. So circuit consists of energy storing device but doesn't consist of sources, energy sources or voltage source or current source. So what will happen? So the energy storing device, so that will, the energy stored in the circuit, that will inject the energy into the circuit. So in the case of natural response, the circuit without source, and the response is purely based on the energy stored in the circuit. So the behavior of the circuit is purely based on the energy stored in the storing device. So that's called natural response. So the circuit consists of this energy storing device. Right? If you switch on the switch, means what will happen? The energy stored in the circuit will inject into the circuit, that will flow to the resistor. After some time, it will reach to a saturation state. So that's called transient response. Actually, natural response is also called transient response. So what is transient response? The circuit consists of energy storing device, but it doesn't contain any source. The energy stored in the circuit will inject into the circuit, that will flow through the resistor, and for a particular time it reaches to a saturation state. So that's called transient response. Other one is called post response. What is post response? The circuit containing source. The behavior of the circuit is purely dependent upon the sources available in the circuit. So that is called post response. So what is meant by post response? The circuit consists of energy storing, voltage sources. The behavior of the circuit is purely based on the sources. So that's called post response. So what do you mean by natural response? Without source. The behavior of the circuit without source. So the behavior is purely based on the circuit. So that's called natural response. What is post response? The circuit with source. The behavior of the circuit is purely based on the sources available in the circuit. So that's called post response. So you must be familiar with these three initially. Now we are going into transient in DC RL circuit. So you may ask a question whether there is a difference in transient in DC RL circuit or AC RL circuit. There is any difference? The only difference is the source. In the DC RL transient, the source is DC source. In the AC RL transient, the source is AC source. So what is the value of DC? They are given E. In AC, what they will give? It is Em sin omega t. So that's the only difference. The procedure is the same. So here, what is our aim means? You have to find the transient current. So when you switch on the switch, right, immediately the steady current will not flow, right? So it will take smaller time to reach the steady state. So before the steady state, after switch on the switch, the current flow into the circuit is called transient current. The current in the transient state, that's called transient current. So our aim is to find the transient current, that's called I of t. So how to solve this means, so in all the circuit, whether it is RL circuit, whether it is RC circuit, whether it is RLC circuit, the procedure is the same. So what we have to do, first write the Kirchhoff's voltage law equation. Then substitute the voltage value in time domain. Substitute the formula for voltages in time domain. Then apply Laplace transform. Then find I of s. Then apply partial fraction to separate the term. Find the value of A, B, even C. Then substitute the value in I of s. Then apply Laplace inverse. Then you will get I of t. So this is the standard procedure for all the transient, RL transient or RC transient or RLC transient. Whether it is AC or whether it is DC, the procedure is the same. You have to write the Kirchhoff's voltage law equation. You have to substitute the formula in time domain, voltage across the resistor, voltage across the inductor in time domain, right? Then you have to apply, so you have to find I of s, right? Then apply partial fraction to separate the term. Then find the value of A, B, C, D, whatever it may be. Then substitute the value of A, B, C in I of s. Then you have to apply Laplace inverse, we will get I of t. So that is what our aim. So here, first we are taking RL transient. So the switch S is R, L, the voltage across the resistor is ER, voltage across the inductor is EL, apply voltage is E. When you apply Kirchhoff's voltage law, E is equal to voltage across the resistor plus voltage across the inductor. Algebraic sum of voltage in a closed circuit is equal to 0. That's what Kirchhoff's voltage law. So E is equal to ER plus EL. So E is equal to ER, voltage across the resistor in time domain. So don't think it of the frequency domain, that's different. All the other unit, you have to use frequency domain. Only in transient you have to use time domain. So voltage across the resistor is I into R, both are same. Frequency domain as well as time domain are the same, I into R. What is the voltage across the inductor? That is equal to L into di by dt. So you have to substitute the value of EL, voltage across the inductor, in time domain. That's very important. Then apply Laplace transform. So E into 1. So that's the meaning of this. So what's the Laplace transform of 1? 1 by S. So it is E by S. That is equal to R into I. What's the Laplace transform? I equal to I of S. Plus Laplace transform of L into di by dt. So the Laplace transform of L into di by dt is S into L into S into I of S minus I of 0. What is this I of 0? So actually inductor is a energy storing device. Sometimes before the switch is switched on, right? So the inductor consists of some energy. Due to that there is a current flow. So that current is I of 0. Initial current in the inductor. So how the initial current will come? Already stored energy. Right? We are closing the switch at t is equal to 0. That's also very important. When you close the switch, right, then only the supply will enter into the resistor or current will enter into the resistor or inductor. But inductor is an energy storing device. So already stored energy is there means because of that there is a current. That's what I of 0. So that also you have to take into account when you are solving the problem. But when you are solving the derivation or you will find the derivation for I of t for RL circuit, we are assuming I of 0 is equal to 0. So assuming I of 0 is equal to 0. So E by S is equal to, take I of S outside, I of S into R plus S into L. So here you must understand, so from this you can find I of S is equal to E divided by, cross multiply it, E divided by S into R plus S into L. So here in all the case the denominator must be S or S plus A or S minus A. In that form it is easy to apply Laplace inverse. So for that what we are doing here means, so here it is S into L. So we are taking a L outside the circle, what outside this bracket. We are taking out this L. So what will happen? If you take L, it's R by L. So that's what E by L, S into S plus R by L. Right? Because we are taking L outside, we are taking the L to the numerator, so E by L, S into S plus R by L. So our easy for substituting Laplace inverse very easily. So that's why we are taking it as S into S plus A form. Then it is very easy to apply Laplace inverse. So now I of S is equal to E by L divided by S into S plus R by L. So now we have to apply partial fraction. By applying partial fraction you can separate the term. You know that I of S is equal to A by S plus B by S plus R by L. Now our aim is to find the value of A and B. So actually you follow some method in mathematics to find the value. Already you are familiar with partial fraction. So you calculated A, B in some different manner. So now I am going to give you another method of calculating A. So there is a formula for calculate A. A is equal to I of S into denominator of A at denominator of A is equal to 0. So you can substitute this formula directly. You can calculate A. Whether you can follow this method or already familiar method in mathematics, whatever method you can use, you find the value of A. So in my approach, A is equal to, so the formula is I of S into denominator of A and denominator of A is equal to 0. Then what is B? I of S into denominator of B and denominator of B is equal to 0. What is C? I of S into denominator of C and denominator of C is equal to 0. So we are going to calculate A. So if it is easy, then you follow this method, or already you are aware of that method that is used in mathematics, you follow that method also. So what is A? I of S into denominator of A and denominator of A is equal to 0. What is I of S? E by L S into S plus R by L. So that is I of s into denominator of a. What is denominator of a? It is s. I of s into denominator of a at denominator of a is equal to 0. What is the denominator of a? Yes, s is equal to 0, right? Denominator is s is equal to 0. So this s get cancelled. You substitute s is equal to 0 here. So e by l divided by r by l. So a is equal to l get cancelled. So a is equal to r by l. You can calculate a directly. So this is one method, right? Otherwise you can follow the method already you are using in mathematics. That also correct. You can use that also. So a is equal to e by r. Similarly we are going to calculate b. What is b? I of s into denominator of b and denominator of b is equal to 0. That means s plus r by l is equal to 0. Then what is s? S is equal to minus r by l. So s is equal to minus r by l. I of s into denominator of b and denominator of b is equal to 0. That means s is equal to minus r by l. So this s plus r by l, this s plus r by l get cancelled. Then s is equal to minus r by l you substitute. Again l get cancelled. So b is equal to minus e by r. So what is b? b is equal to minus e by r. Now we are going to substitute a and b in I of s. What is I of s? A divided by s plus b divided by s plus r by l. There we are going to substitute the value of a, that is e by r, minus e by r divided by s plus r by l. Now we are going to apply Laplace inverse. So Laplace inverse of I of s, that is equal to e by r into Laplace inverse of 1 by s. You can take e by r into 1. This can be written e by r into 1 by s. So you can take e by r outside. Laplace inverse of 1 by s minus, here also you take e by r outside, the Laplace inverse of 1 by s plus r by l. Right? So now we are applying Laplace inverse. What is Laplace inverse? Laplace inverse of I of s equal to e by r into Laplace inverse of 1 by s minus e by r into Laplace inverse of 1 by s plus r by l. So here Laplace inverse of 1 by s is what? 1. So Laplace inverse of what is this? S plus a. Laplace inverse of s plus a is e power minus at. That's the formula. Laplace inverse of 1 by s plus a is equal to what? It is e power minus at. So e by r, Laplace inverse of 1 by s is 1, so it is e by r minus e by r into e power at, where here into what is a? R by l. So e power minus at, minus r by l into t. So e by r is common. Now to take outside, so I of t is equal to e by r into 1 minus e power minus r by l into t. So this is the formula to calculate the transient current. The current during the transient state, that's called transient current, I of t. So what is I of t for RL circuit? E by r into 1 minus e power minus r divided by l into t. So sometimes, in the problem they will ask I of t alone. They will not ask I of t alone. They will ask what is the voltage across the resistor transient, what is the voltage across the inductor transient. So now we are going to derive the formula voltage across the resistor at transient. During transient, what is the voltage across the resistor? You know that ER is equal to I into R. What is this I? I is nothing but transient current I of t. So ER is equal to R into what is I of t? E by R into 1 minus e power minus R by L into t. So this R get cancelled. So ER is equal to E into 1 minus e power minus r by l into t. So this is the formula to calculate the voltage across the resistor during transient. So ER is the transient voltage, right? Transient voltage across the resistor. The formula is E into 1 minus e power minus r by l into t. So now what is the voltage across the inductor? So voltage across the inductor is L, EL. You know that voltage across the inductor is equal to L into di by dt. So L into d by dt of I. What is I? I of t. What is I of t? E by r into 1 minus e power minus r by L into t. So if you differentiate with respect to t, then simplify you will get EL is equal to E into e power minus r by L into t. So what is the voltage across the inductor at transient? How will you calculate that? By using the formula EL is equal to E into E power minus R by L into T. So now we can see, so how will you calculate the RL transient for AC circuit? First we calculated for DC circuit, now RL transient for AC circuit, AC RL circuit. You look into the circuit, what is the difference? The only difference is the voltage source. Initially it is the DC voltage source, now it is a AC voltage source, that is Em sin omega t. Similar to previous derivation, you have to solve it. No change in that. Instead of E, what you will get? Em sin omega t, that's all. So here E is equal to ER plus EL. So what is E? Em sin omega t. So what is ER? I and R. What is EL at time domain? L into dA by dt. Then apply Laplace transform. So Em, what is the Laplace transform of sin omega t? Omega divided by S square plus omega square. So that is the Laplace transform of sin omega t. You have to apply the Laplace transform of sin omega t. So Em into omega divided by S square plus, so sin omega t Laplace transform is, so Em is constant, so Laplace transform sin omega t, omega divided by S square plus omega square, that is equal to R and I of S, L into S and I of S minus I of 0. So for derivation I already told that I of 0 you have to assume as 0. But problems, if they given I of 0 means you have to substitute that I of 0 there. But the derivation no need to consider I of 0. Then you find I of S. I of S is equal to, if you cross multiply, you have to take I of S outside. Then if you cross multiply, you will get Em omega. So already I told that the denominator must be S plus A form. So that's why you have to take L outside from S. So Em omega L into S plus R by L, S square plus omega square. You find the value of I of S. So take I of S outside, then cross multiply. So here S consists of L, S term consists of L here. You take L outside. Then if you simplify, you will get I of S is equal to Em omega divided by L into S plus R by L, S square plus omega square. So from this I of S is equal to, so you take the L numerator, Em omega by L divided by S plus R by L into, so this is what the form, this of the form A plus B the whole square, right? A plus B the whole square. Actually, so what is this form means? S square minus J square omega square. That means A minus B the whole square, right? So here actually S plus omega square, this can be written as S square minus J square omega square. Correct? J square is equal to, what is J square? J square is equal to minus 1, so minus get plus. So this is of the form not A plus B, it is of the form A square minus B square. So this can be written as J omega the whole square. Okay. So what is A square minus B square? A plus B into A minus B. So that's why I of S is equal to Em omega divided by L divided by S plus R by L, S plus J omega, then S minus J omega. So then apply partial fraction. I of S is equal to A divided by S plus R by L, B divided by S plus J omega, C divided by S minus J omega. Then calculate the value of A, B, C. So already we discussed a method. So I of S into denominator of A and denominator A is equal to 0. So use that method, or the method you already followed for max. You use that method, you find the value of A, B, C. Then substitute the value of A, B, C here. Then you apply Laplace inverse, then you will get I of t. So this is the formula to get the I of t for this AC RL transient. So you can try it, right? So I of S, so this is what I of S, applying partial fraction. After applying partial fraction, this is I of S. So here find the value of ABC by using any method, right? Already you are familiar with some method in maths, you follow that method or use that method. I of S into denominator of A and denominator of A is equal to 0. So I of B means I of S into denominator of B and denominator of B is equal to 0. C means I of S into denominator of C and denominator of C is equal to whatever method you are more comfort, use that method and find the value of ABC, substitute the value of ABC here, then apply Laplace inverse, we will get I of t for AC transient in RL circuit.